All right. Well. What do we have here? Let's read the question. Let's just get started. Let f be the function defined on the closed interval from -3 to 4 with f of 0 equals 3. That's probably pretty important. We got to make a note of that. The graph of f prime, the derivative of s, consists of one line segment and a semicircle. All right, that's cool. That's what's up. We can work with that. On what intervals is f increasing? Well, it's talking about f. Now remember, if it says what intervals is f increasing means take the derivative. And when is it greater than 0? When is it positive? Well, guess what? We are given the derivative of the graph here. So really, we just look and see, when does this have positive y values? Well, it only has positive y values right there. So we could really just come in right away in part A and say, well, f, my friend, is increasing on -3 to -2. And you can put brackets if you want. We usually don't include the zeros. It's not a big deal. It's going to be fine either way. Here we go. Because f prime is positive. Bam. Easy speasy, lemon squeezies. Let us continue to part B. All right, what do we have here? Let f be the function defined on the closed interval with f of 0 equals 3. The graph of f prime, the derivative of f, consists of one line segment and a semicircle. Find the x coordinate point of each point of inflection of the graph of f. Justify your answer. Well, point of inflection is our second derivative, and it needs to change signs. So we got to do a little bit of work, and that's not a big deal. We just got to find when is our second derivative equal to 0 or undefined, and does it change signs? Well, right here it's undefined, and right here it's equal to 0. So how do we justify our results here? Well, at x equals 0, f has a point of inflection because f double prime changes from negative to positive. It changes signs. Why? Well, right here it's undefined. And what is your instant slope from the left? It's, well, quite frankly, you can see here, it's got to be negative. And from the right here, it's positive. So the second derivative changes signs. And now we can say also at x equals 2, f has a point of inflection because f double prime changes from positive to negative. Right, we change from right here positive to negative. Positive to negative. Thank you very much. Thank you for shopping. All right. Beautiful. We are done. Let's move on. Let us move on. Part C. Find an equation for the line tangent to the graph of f at the point 0, 3. So this should be y minus 3 is equal to mx minus 0. What does m mean? Well, m really means take the derivative and plug in the x value. Well, guess what we're given? We're given the derivative, and at x equals 0, your slope, according to the graph, is -2. So y minus 3 is equal to -2, x minus 0. Bam, we are done. Nothing else to do. Nothing. Absolutely nothing. Nothing else to do. Moving on to part D. All right, my friends. Let f be the function defined on the closed interval with f of 0. Blah, 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 blah. Find f of negative 3. Find f of 4. Well, I got to find the original x value at negative 3 when we're given the derivative. So that to me tells me, I'm going to leave some space here for a moment, that we're starting at 0. It's to negative 3. That's the value we want. And we need to take the antiderivative of our antiderivative. Sorry, let me write this as f prime of x dx. There it is. We need to take the antiderivative of my derivative to get to position. But what is my initial condition? Because if I put 0 here, or not initial condition, but if I put 0 on the integral, well, what is my initial value? Well, at f of 0, it's 3. So we got to make sure we do 3 plus. Well, we're going to get 3 minus, because it's going to be from negative 3 to 0, from most negative to most positive. That's it. And ba-ba-da-ba-bwa. There it is. Well, what does the antiderivative of this mean? Well, my friends, that means we're taking the antiderivative, and that means the area under the curve from 0 to negative 3. Or negative 3 to 0. Well, what is the area of this right here? Well, it's 1 times 1 divided by 2. This is 1/2, or 0.5. This right here is 2 times 2, which is 4, divided by 2, which is negative 2. Negative 2 because it's in a negative region. So this is 3 minus 0.5 minus 2. 3 minus negative 1.5, which is positive. This becomes positive, so this is 4.5. So now we know this is equal to 4.5. Has to be 4.5. Without a doubt. Without a doubt, my dear friends. Okay? Okay? Thank you for shopping. Thank you. Thank you very much. Thank you for shopping. Moving on to the next question I hand here. Find f of 4. Same difference. F of 4 is equal to, well, at this point we're starting with 3 plus 0 to, whoa, that 0 is way out of the picture. F prime of x dx. This is the integral from 0 to 4, and this is a tricky one, because when we want to find the area from 0 to 4, that is the area from here to here. Well, how do we do that? Well, let's think of a box. We're going to find the area of the box, which is what? 4 times 2. That gives me a total of negative 8. Okay. And now we're going to subtract, which is the area under the curve from a circle. Well, we know this is pi r squared, which is pi. The radius is 2. Okay. It becomes 4 pi. But it's a semicircle, so we divide by 2. Bam. So it's negative 8 minus negative 2 pi. So let me rewind. We found the area of the entire thing. Okay? The area of the entire thing. The area of the entire thing is going to give me negative 8. Okay? Now we got to subtract by. What we got to do is we got to subtract by these little regions here. Take it back. Let me draw this one more time. I'll do it perfectly for you. I'll explain this perfect. This entire box here is negative 8. What I want to get rid of is this area of this circle. I want to get rid of this, right? Because if I get this box and I get rid of everything underneath that, I'm going to be left with just these regions right here. I have the area of the box subtracted by the area of the pink. Subtract this, that's gone. We're going to be left with this right here. All this in here. So that's what we want. That's why it's -8 minus what happens to be -2 pi, because that's the region underneath. So we're going to get 3 plus -8 plus 2 pi, which is 3, which is really 3 plus -8 is -5 plus 2 pi. Bam, we're done. We're golden. Thank you for shopping. And that's all we do, my friends. Took 11 minutes. We're on pace. Bada bing, bada boom.